let's do 3.1, 3.2, 3.3. Well, that's my hope, is to do all of those. We will need to see how long this video lets me record. Oh, 3.2 and 3.3. Okay, 3.1, 2, and 3 are going to be about adding and subtracting fractions, like fractions, and unalike fractions. So let's go ahead and start. It might just say like. I've always said alike. For alike fractions, they are alike because they have the same denominator. So when you have the same denominator, adding and subtracting fractions is very easy, way easier than when they aren't the same. A few examples of that. If we have 2 over 5 plus 4 over 5, they're fractions. There's an operation sign. What is it telling me to do? It wants me to add. First and foremost, do they have the same denominator? If they do, what you do is you add the top and you keep the bottom. 2 plus 4 is 6. Keep your denominator. Okay? Second example, also like fractions. The reason why they are alike is because their denominator is the same. Kind of makes our job a little bit easier. You add the top, 1 plus 2, which is 3, and you keep the bottom, which is 7. Okay, I'm going to do an example where I really don't like how it will not let me move my screen. There's like a delay. Okay, let's say we have 4 over 9 minus 2 over 9. Y'all, it's the same thing, adding or subtracting. Look at your denominator. Do they have the same denominator? Yes. So we will form the operation in the numerator, keep the denominator. 4 minus 2 is 2 over 9. So that is adding and subtracting fractions that have the same denominator. You have to have the same denominator to be able to add and subtract fractions. Now let's say they are not alike. So this would mean that they have different denominators. Okay, so what we do is we rewrite the fractions with the same denominator. We need them to be the same denominator so they can be added or subtracted. Okay, I wish I could collapse. Oh, yay. Okay, so let's do an example. First example is 3 over 5 plus 2 over 4. Okay, so if I look at my denominators, I notice that they actually do not have the same denominator. They're not the same. If I look at them, they're not the same. So what I need to do is rewrite them with the same denominator. So I'm actually going to bring them over here. I like to write them on top of each other, and I know I'm going to rewrite them with a new denominator. So what you can do is look and see what is the smallest number that both 5 and 4 can divide equally. That's also called an LCM, which is a least common multiple. So what we're going to do is take multiples of each of our denominators. If we take multiples of 5, we have 5 10, 15, 20, 25. Just write out a few. And then let's take multiples of our 4. 4, 8, 12, 20, 24. LCM, actually go ahead and write it out, least common multiple. I did the multiples. Now I'm worried about the L and the C, the least common. Well, common means that they both have it, right? Like they have it in common. And if I look, the first number that I got to that 5 and 4 have in common is 20. That's also the smallest number they have in common, which is why it's the least common multiple. That's our new denominator, okay? These 20s are going to go on the bottom. So essentially what I'm doing is I'm taking this 3 over 5 and this 2 over 4 and I'm rewriting it. It's still going to be equivalent, right? That's why they have the equal signs right there. They're still equivalent fractions, but they're going to be larger because rewriting them with the same denominator means that I can now add or subtract them. So let's look at this mathematically. What did I do to 5 in this denominator to get to 20? Well, I multiplied it by 4, right? Well, what you do to the bottom, you have to do to the top. 3 times 4 is 12. And what did I do to this 4? I multiplied it by 5. What you do to the bottom, you have to do to the top. 2 times 5 is 10. Yo, these are my new fractions. What I'm going to do is I'm going to look. This 3 over 5 became 12 over 20. This operation sign just comes down. It's positive. That's a plus sign. And then my second fraction became 10 over 20. Now my denominators match, which means I add the top, keep the bottom. 12 plus 10 is 22 over 20. Those are both pretty large numbers, and I notice they're both even. So I can actually divide both of them by 2, right? If I do 22 divided by 2 and 20 divided by 2, well, 22 divided by 2 is 11. 20 divided by 2 is 10. That is your final answer because it's in like complete reduced form. Okay, let's do one more. For this example, my nose is running, I'm sorry. We have 3 fractions that it wants us to add. And they all have different denominators. Because they all have different denominators, they're all going to be rewritten. So I'm going to write my 1 over 2, I got my 3 over 4, and I have my 2 over 5, right? And I know I'm going to rewrite them. It's still going to be equal, but it's just going to be larger. Well, how do I know what to write it as? I'm going to show you a shortcut here. Finding the LCM is great, and that works every single time. But sometimes when you have 3 numbers, you don't want to find the LCM of them. And what if their LCM is really large? It won't let me move back up. What if their LCM is pretty large? Well, I mean, then you're writing so many multiples, right? So there is a shortcut. What we can do is look at all of our denominators, and for our common denominator, we can multiply them together. 2 times 4 is 8. 8 times 5 is 40. That's our common denominator. If you do the least common multiple, which go ahead, try it, you're also going to get 40. Okay? So 40 is our new denominator for all of these so that we can add them. Mathematically, I had to do 2 times 20. What you do to the bottom, you have to do to the top, right? Mathematically, I had to do 4 times 10. What you do to the bottom, you also do to the top. Mathematically, I had to do 5 times 8. What you do to the bottom, you also do to the top. These are my new fractions. I'm going to go ahead and write all these out, okay? Got all different kinds of colors going on. The 1 over 2 became 20 over 40, right? This operation told me to add. And then this 3 over 4 became 30 over 40. This operation told me to add. 2 over 5 became 16 over 40. Question, do my denominators match? Yep, perfect. Let's add. 30 plus 20 plus 16 is 66 over, keep your denominator. That actually can be reduced though, right? Because they both can be divided by 2. And if I do that math, I get 33 over 20. Okay, awesome. Okay, that was actually the only examples I had pulled for adding and subtracting like and unlike fractions. The next video, if I can get it recorded today, will be order of operations, exponents, and inequalities. But if not, I'm going to try to record at home, okay, like maybe tomorrow or something. Okay, thanks, though.